Okay, we're talking about ice today. So we're going to talk about glaciers and pack ice. First of all, you need to know what a glacier is and how it works. So let's go and look at it, okay? Now, if you imagine, back when we talked about catchment areas, if you imagine a ravine between mountain ranges, you would see rain fall and you would see it form streams and rivers and go out to a body of water, an ocean or something. But what happens if this situation happens in a place where it's always below freezing and it doesn't melt? Well, what's going to happen is the precipitation falls as snow instead of rain, and as it lands, it's going to fill it with snow, right? This is all going to get full of snow. And it's not going to melt. And every year it might snow a bit more, and that snow is going to accumulate. Now, is it going to fill up with snow until it's bigger than the mountains? No. What will actually happen is that the snow will accumulate until it's so deep that it's so heavy that it's going to get compacted down by the weight of the snow. And it's going to become ice. And you've seen this on the roads outside when it snows and we don't remove the snow and the cars drive over it on the roads. You'll see layers of ice that used to be snow. It didn't start as ice, and it gets slick. So you know that snow, if you squeeze it enough, it actually does become ice. And that's what's going to happen. And you're going to end up with a glacier, a huge area full of ice, a giant ice block there. Now, as it keeps snowing, it's not going to just accumulate forever. So what's going to end up happening is when it gets so heavy, and this terrain is sloped downwards towards the ocean or whatever, that it gets so heavy that even though it's solid ice, it's going to grind its way down slowly. And it might just move a little bit or every week or every month. Just very little amount, but it is actually sliding down and it's grinding against the rock and breaking the rock, and the rock is breaking the ice. And eventually it gets down to the water and you end up with like a wall of ice, which is the thickness of the glacier. And that thing is going to go into the water, and it's going to be like a shelf hanging over the water until it gets weak enough, okay, and it's hanging over the water and it actually falls off and it breaks. Little chunks, not little, actually quite big chunks, fall off and break and land in the water. And you end up with icebergs. So this is the cycle of a glacier. It snows, it gets compacted on ice, into ice. The ice slowly, under its own weight, shifts slowly over a period of weeks or months. And every once in a while, pieces of ice fall off into the water and go away. That's what a glacier does. A glacier it's pure water. It's from the snow, right? It has no salt. And it constantly renews itself with snow and breaks off into the water. Okay, next thing we're going to look at an ice flow or pack ice. They are the same thing. They are when you have out in the ocean, you have cold air, and it's cold enough that the ice starts to freeze. The ocean surface starts to freeze and form a layer of ice. Okay, if you have lots of these, all close together touching, we call it pack ice. If you just have one that's floating around on its own, we call it an ice flow. But it's the same thing. Now there's something really interesting that happens when this forms, okay? And what happens is the water molecules freeze. But as it gets colder and water underneath freezes, this ice kind of attracts water molecules more than the salt. So it actually pulls out the water to form the ice. And this ice we call brackish, meaning it might have a bit of salt, but it has a lot less salt than the water it came from. It's pulling out the water molecules and leaving a lot of the salt behind. Okay? And this just floats on the ocean. Okay, so this is looking at the ocean from the side. You'd end up with a thin layer of ice. Just as if you put a cup of water in the freezer, it would freeze along the top. Right? Now, unfortunately, as we've talked about, we have global warming, which is causing a lot of changes. It's causing these glaciers to melt. Glaciers that have been there for thousands of years, they are melting faster than the snow that's coming to replace the melting ice. So they're sliding away, they're melting. It's basically a lot of glaciers have already disappeared. Likewise, pack ice is melting. Now, it's interesting that if you look at the planet, the South Pole has land. It's a continent. And on top of that land, there are kilometers thick of ice. And that's melting too. But in the North Pole, there is no land. It is floating ice. The North Pole is all one giant ice sheet. And it's not even that thick. You're just talking about a meter or two normally. Some places it gets thicker or whatever, but it's not very thick at all in the North Pole. And submarines go underneath the North Pole all the time. So that's kind of cool if you think about it. Now, what happens as global warming happens? Well, glaciers will melt and disappear. Unfortunately, they will reflect the sunlight less because dark Earth absorbs the sun more than white snow. Likewise, when this melts, this will do the same thing. And we've got to look at, I have a list of things that happen, okay? So let's go through that. So consequences of melting glaciers and pack ice. Well, one of the big ones is the sea level is rising. The sea level has already risen, just in 25 years, has risen about 25 centimeters. So that's about 10, so it's risen about that much. And you're talking about the oceans, like humongous oceans have gone up that much. And they can go up much, much more. They are predicting about another meter of rise by 2100, which is only about 80 years away. So that's really kind of scary because a lot of humans live on the coast. Our cities are on coasts. And 1 meter of rise vertically can be kilometers of water going inland, since our beaches and our land is sloped so shallowly. Another thing is disturbance of the thermohaline circulation. So when these humongous amounts of ice are melting, they are adding fresh water to the ocean. Fresh water is not as dense as salt water. And near those, that's where, in the northern areas and the South Pole, this is where the warm water goes and sinks. But if we're adding fresh water to it, we are diluting the salt, the concentration of salt, and that water isn't going to want to keep sinking. And our ocean circulation is slowing down, which has causes big problems in terms of not distributing the heat around the planet. And the last one is there's lots of wildlife that depends on salt water. If we're adding a lot of fresh water from this melting ice, it can affect those too. But at a global scale, these two are very big issues. Okay, so just as a recap, just so you know what's going on, you have to know about glaciers, which are ice that form on land from falling snow that gets compacted into ice sheets, thick ice sheets. These normally will slowly move under their own weight and break off as snow keeps building on them. However, with global warming, it's melting and going into the ocean faster than ever before. Pack ice and ice flows are ice that forms on the surface of oceans because of the cold air. It pulls water out, so the actual ice has less salt than the water it came from. If this melts, it's adding more fresh water to the ocean. And we have 3 big problems caused by the melting ice, okay? We have an increase in sea level. We have the global circulation of oceans. The thermohaline circulation can slow down or get affected by all that melting ice. And a lot of animals can be in trouble. Okay, there you go. Glaciers and pack ice. Ciao.